So the next point you are going to focus on is the parametric equations. So it's basically the derivative of parametric equation. So let's say we have a function y which is equal to x squared plus 2x plus 1. So this function can be written in terms of another parameters, so that can be simplified. So you can write it, you can have this form. For instance, x is equal to 3 theta, and then y is equal to 9 theta square plus 6 theta plus 1. So here the objective is to write a single function in terms of another variable which is called parameters. So how can we go to the parametric equation, to the normal equation? We just substitute the value of theta into the second equation. Okay, this one is called parametric equation. So how to find the normal function from the parametric equation? Since in my first equation I say that x is equal to 3 theta, so I just need to replace the value of theta into the second equation. So in other words, here I first need to make theta subject to formula. So we have theta which is equal to x divided by 3. So now I need to take that x divided by 3 and then bring it and plug it in the second equation. So the second equation will be y which is equal to 9x over 3 square plus 6x over 3 plus 1. So if I simplify this, I'm going to end up to x squared plus 2x plus 1. So now the objective is not to make the parametric equation, but how to derive a parametric function. So to derive the parametric function, we need to use what is called chain rule. So if you have dy over dx, so it means the derivative of the function y with respect to x. So this is applied to the normal function, in function in which you have x variable or a non-parametric function. So this is the same as, so this is basically a fraction. So dy is the numerator and dx is the denominator. So if you divide both sides by the parameters, so the change of the parameters, so let's say you divide your dy by d theta, and then you also do the same, you also need to do the same thing to the denominators so that the expression doesn't change. So that can also be written as dy over d theta divided by dx over d theta. So you actually have the division of two fractions. So that's gonna be dy over d theta multiplied by the inverse of the second fraction, which is d theta divided by dx. So this is called chain rule. So in other words, like in this case, you have a parametric function, which is so in the first function we have x, which is expressed in terms of theta, and then in the second function we have y, which is expressed in terms of theta. Then if they want you to derive the function y with respect to x, you have a parametric equation. You have a parametric function, then you just need to apply this formula. So it's called chain rule. Like in this case, to derive this function, we first need to determine the derivative of the function y with respect to theta. So that's gonna be 18 theta plus 6. So this is the derivative of y with respect to theta. So now we need to find the derivative of theta with respect to x. So if I say derivative of theta with respect to x, so that is the same as the inverse of the derivative of x with respect to theta. So the reason why I need to write it in this form is because we have, so the function is theta, and then the variable, the function is x and the variable is theta. So we are deriving the function with respect to theta. So I first need to determine the x over the theta. So that's gonna be 3. So I need to apply it to the first equation. So now I have everything that I need. So then the derivative of y with respect to x will simply be equal to the multiplication of the derivative of y with respect to theta. So I've already worked this out. So I got 18 theta plus 6, and then I have to multiply it by the derivative of theta with respect to x. So this is the same as the inverse of the derivative of x with respect to theta. So as I've already determined the derivative of x with respect to theta, which is equal to 3, then the inverse will be 1 over 3. So 1 over 3 represents the derivative of theta with respect to x. So now I need to multiply that 1 over 3 with what I have here. So if I multiply these two, I'm gonna get 9 theta plus 2. So now let's try to do another example. Okay, before we do that example, I will also explain you this. So what if they want us to determine the second derivative of the function y with respect to x, but the parametric equation, the parametric function is given. So can still apply the same principle. So if we have the second derivative of y with respect to x, so that can be written as the derivative of the first derivative of y with respect to x, and then everything with respect to x. So far I haven't yet applied the chain rule. So to apply the chain rule, as you can see, we have the first fraction on top, which is the derivative of the derivative of y with respect to x. So this is the numerators, and then the numerator is just dx. So if I divide both sides by a parameter, which is the derivative of the parameter, okay, let's assume that t represents the parameters. So if I divide both sides by dt, so I also divide the denominator by dt. So I'm going to end up with this. So I have the derivative of y with respect to x over dt divided by dx over dt. So I actually have my first fraction, which is that one, and the second fraction, which is this one. So we have the division of two fractions. So I need to take my first fraction and then multiply it by the inverse of the second fraction. So the first fraction will remain as it is. So I have the derivative of y with respect to x, and then with respect to t, multiplied by the derivative of t with respect to x. So I can use this chain rule when it comes to apply the second derivative of a parametric function. So now let's look at some examples. So we have the first question here. So the parametric function is given. So we have y, which is equal to t minus sine t. And then x is equal to 3 plus ln of sine of t. So now the question is to determine, so you need to find the first derivative of y with respect to x, and in the second question we need to find the second derivative of y with respect to x. Okay, let's start with the first question. So the starting point is to write the the formula that is used to derive a parametric function. So we have dy over dx is equal to the derivative of the function y with respect to theta multiplied by the derivative of theta with respect to x. So now I first need to determine the derivative of y with respect to theta. So I can determine it from the first equation, because I have a function y that is expressed in terms of theta. So so the derivative of y with respect to theta will give, so we have 1 minus cos theta. So now we need to find the derivative of t with respect to x. So if from the second function I can find the derivative of x with respect to t, but I'm not supposed to. So this is not the final. This is not what I need. But I need to determine. So this t should be on top. So dx should be the denominator. So I first need to determine this, because the second function is written in terms of t, so we have x which is equal to something which is written in terms of t. So therefore we first need to determine the derivative of x with respect to t. So that's gonna give, so if you apply the formula of ln, because this is gonna cancel out because it's a constant, so the derivative of a constant is 0. So we just need to derive ln of sine t. So that's gonna be cos t divided by sine t. So this is equal to cot t. So now to get the derivative of the function y with respect to x, so just need to multiply these two. So here I have dx over dt, so that dt over dx is equal to the inverse of cot, which is equal to 10. So now we can multiply. So we have the first expression and so we have the first expression which represents dt over dx, and the first one is this one. So therefore we can say that dy over dx is equal to 1 minus cos t multiplied by tan t. So that can also be written in terms of cot. So that is the same as 1 minus cot t multiplied by 1 over cot t. So now we have to determine the second derivative. So let's create a new slide quickly for that. So the starting point is to write the formula. So the second derivative of the function y with respect to x, so in the parametric form is, so we first have the derivative of the function y with respect to x. So we need to divide that by dt, and then you multiply by dt divided by the derivative of x. But since I've already determined the first derivative of function y with respect to x, so now I first need to determine the derivative of the function that I've just derived. So in other words, I can just replace dy over dx, because I've already determined my dy over dx. So from the previous slide, so this is what I got. So I have 1 minus cos t multiplied by 1 over cot t. So I need to derive this with respect to t, and then I need to multiply it by the whole thing by the derivative of t with respect to x. So remember, I've already determined this derivative, so I have it. So I got it from the previous slide. So I have 10t. So I need to multiply the whole expression by 10t. So I can simplify the expression that is within the bracket a little bit. So if I have 1 minus cos t multiplied by 1 over cot t, so that is equal to, so I can express this in terms of 10 first, and then if I multiply, so the whole thing multiply sine t over cos t. So that's gonna give sine t over cos t multiplied by sine t, because the cos will cancel out. Sine over cos gives 10. So you actually have 10t minus sine t. So this is actually the first derivative, the simplified form. I can also say that dy over dx is what I found here, 10t minus sine t. So it's the same. So now to find the second derivative, you first need to derive the equation that I got from the previous slide. So I need to derive 10t minus sine t. So we need to derive it with respect to t. And then after deriving, I'm going to need to multiply it by dt over dx, which is 10t. So the derivative of 10t gives sec square t, and the derivative of sine t gives cos t. So now I haven't yet done, I still need to multiply the outcome of the derivative with 10t. So this is the final answer. So I can also see in the book they just express 10t in terms of sec. In other words, this answer can also be written as, so we have sec square minus cos t multiplied by, because 10t can be written in terms of cot, that's the inverse of cot, so just multiply it by 1 over cot, so this doesn't make any difference. That's it. So now let's look at another example. So we'll now do we have the parametric function just given by, so we have y is equal to theta plus sine of theta, and then we have x which is equal to 1 minus 2 cos of theta. So we want to find the derivative of the function y with respect to x, and then they want us to find the derivation of that function when theta is equal to pi over 6. So here we need to find both the first derivative and the second derivative. Okay, let's first start with the first derivative. So the starting point is to write the chain rule formula. So we have dy over dx is equal to dy over d theta multiplied by v theta divided by dx. So what is dy over d theta? So we need to derive, so we need to look at the first equation. So the first equation is y, which is equal to theta plus sine of theta. So therefore dy over d theta will be 1 plus cos of theta. So now we have to determine the other derivative, which is d theta over dx. So this is the same as the inverse of dx over d theta. So now what's gonna be dx over d theta? So we just need to derive the second function with respect to theta. So the second function is, so we have the function x, which is expressed in terms of theta, so we need to derive it. So if we derive that, we get, so remember that the derivative of cos is negative sine, because we have another sign in front of cos. So if you multiply both sign, we're gonna have a positive. So we have 2 sine of theta. So this represents dx over d theta, but we need to get d theta over dx. So d theta over dx is just the inverse of what I have here. So now the final answer will be the multiplication of these two derivatives. So I'm going to say that dy over dx is, so I have the first derivative, which is dy over d theta. So in terms of theta we have 1 plus cos theta, and then multiply by the second derivative is d theta over dx. So that gives 1 over 2 sine theta. So now if I multiply these two, I'm gonna get, so the answer will be 1 over 2 multiplied by 1 over sine theta plus cos theta over sine theta. So that is also equal to half 1 over sine theta gives cosec theta plus, and then we have cos theta over sine theta, which gives cot theta. So this is the result of the first derivative. So just derive the function y with respect to x, considering that the function is given in a parametric form. So from the previous slide we get we got the first derivative of the function y with respect to x. So we have 1 plus cos theta so that's multiply 1 over 2 sine theta. So I can also write it as a single function. So I have 1 plus cos theta over 2 sine theta. So now we have to find the second derivative of this parametric equation. So first write down the formula. So the second derivative of the function y with respect to x gives, we have the derivative of the function y with respect to x, and then everything with respect to the parameter dt, then we multiply by dt, and then we divide by dx. So I've already determined dy over dx, which is the expression that I have on top here. Okay, just one thing, remember that the variable is theta, not t. I mean the parameter, it is theta, not t. So now we have to derive the function that I've found previously with respect to theta. So I can do it separately. So if I have 1 plus cos theta divided by 2 sine theta. So the objective is to derive this function, which is called y, with respect to x. So now how can I derive this function with respect to theta? So I just need to apply the division rule of derivative. So if you have two functions, we have a function f of x and a function g of x. So now what's gonna be the derivative of the function f of x divided by g of x? So just need to derive. So you first derive f of x, then you multiply by g of x, and you say minus multiply by f of x, and you have f of x, and then you derive g of x. And then at the bottom you need to square g of x. So you need to apply this division rule to derive this function, because this function is made of two I can call them sub-functions. So you have the first sub-function and the second sub-function. So if we derive this, we get, so first derive the expression that is on top. So if we derive it, we get negative sine theta. Then we multiply by the second function, which is 2 sine theta, and then minus one plus cos theta, and then I need to derive the second function, so the second expression, which is the denominator. So if I derive 2 sine theta, I got 2 cos theta. So then I divide this by 2 sine theta squared. Or what I can also do is, to make the thing simple, I can say that this function is written in terms of a constant. So the constant, which is 2. In other words, we have 1 over 2 that multiply the function. So I have 1 over 2 so what I can do is have 1 plus cos theta over 2 sine theta, which is the same as 1 over 2 multiplied by 1 plus cos theta divided by sine theta. So now this constant will not intervene in when I apply the derivative. Otherwise, if I keep it that way, so I'm gonna so the functions that I'm gonna have will be a little bit complex. So if we derive the expression that I have with respect to theta, so I'm gonna have half, and then I apply the quotient the division rule for this to this expression. So I have the denominator, which I have to derive first. So if I derive it, I'm gonna have, so I have negative sine theta multiplied by the second function, which is sine theta. Then I say minus, so I have to write 1 plus cos theta. So this is my first function. So the second term doesn't have to include the derivative of the numerator. and then I still need to derive sine theta, which gives cos theta. And then next I'm gonna have to divide the whole thing by the square of the denominator. So what I can do is I will just copy this part so this is what I have. So now remember that we still need to multiply this by I still need to multiply this by the derivative of theta with respect to x. So if I derive this expression, I'm gonna end up to this, of course using the division rule. So the division rule of derivative is that one. So now the next thing is to multiply this by the derivative of theta over the derivative of x. So we have to multiply it by d theta divided by dx. So what I'm gonna do is I'm gonna copy the function, the expression that I ended with, so we actually need to multiply this by that. So that's mean I also need to multiply it by, so I need to find the value of the derivative of theta with respect to x. I've determined that in the previous slide. So which is 1 over 2 sine of theta. So now the next thing is to simplify the expression that I have. So I have half multiplied by, so negative sign multiplied by negative sign gives negative sine square theta. Then we have cos multiplied by 1, so that gives cos. Then we have cos square theta divided by sin square theta multiplied by 1 over 2 sin theta. So here the trick is to simplify the expression that is on top. So we have sin square theta minus cos theta minus cos square theta divided by sin square theta multiplied by 1 over 2 sin theta. So here we are going to realize that we have negative sin square theta and negative cos square theta. I'm gonna remind you something. If you remember that rule, so it's a Pythagoras rule. Let's say cos square theta plus sin square theta, so that gives 1. So I'm gonna apply this here. So we have negative sin square theta minus cos square theta. So I can group these two and put a negative sign outside because it's a common factor. So I can write it as negative sin square theta plus cos square theta. And then I'm gonna repeat the term in the middle. So we have negative cos theta. And then at the bottom we have this. Then we multiply it by that one. So I'm gonna copy and put it on the new slide. So next we have half multiplied by, so this gives negative 1 because sin square plus cos square gives 1. 1 multiplied by negative gives negative 1. Then we have negative cos theta divided by sin square multiplied by 1 over 2 sin square. And then next we just need to reduce the length of this expression here. So when I have 1 over 4, because you have 1 over 2 there and there, when you multiply them you get 1 over 4. And then we have negative 1, negative cos, so we can bring a negative sign outside the bracket. So we have 1 plus cos theta divided by sin square theta, and then everything multiplied by 1 over sin theta. So this is also equal to negative 1 over 4 multiplied by 1 plus cos theta divided by sin cube of theta. So that's the final answer. So now we're going to do another example that I have here. So we actually have the end chapter exercises. So here I want us to go over the 5th and 6th questions. So the 5th question, you can see it's in your book. So we have, so they give a parametric equation, so of a function which is y is equal to e to the power of 2 theta multiplied by cos theta, and then we have the function x, which is given by e to the power of 2 theta multiplied by sine theta. So now they want us to find the first derivative and the second derivative. So here you can first work out the first derivative. Okay, before touching this question, so there was something that we still need to do in the for the previous question. So they actually want us to determine the first and second derivative of this function when theta is equal to pi over 6. So that means we first need to derive as we did, and then later we have to replace the value of theta by pi over 6. So in this case, I've already found my first derivative. So now the next thing to do is to replace the value of theta. So I have dy over dx, which is equal to 1 plus cos theta divided by 2 sine of theta. So now if theta is equal to pi over 6, then this expression will be, just need to replace the value of theta by pi over 6. So that gives so we have 1 plus square root of 3 over 2, and then so yeah, if we work this out, we are going to get half. So you just need to use your calculator to get the final answer. So same thing in the second problem. So when I have to replace you are going to replace theta by pi over 2, and then you compute. So now we have another question here. They want us to derive the function, the parametric function that is given. So I need to find this and the second derivative. So what's gonna be the first derivative? So we're going to apply the chain rule. So we know already the formula for So that means we're gonna have to solve the first derivative of y with respect to theta, and then we have to solve the derivative of theta with respect to x. So dy over d theta gives, so we have the function y here, which is expressed in terms of theta. So when we derive it, we are going to have the derivative of this function here with respect to theta multiplied by e to the power of 2 theta cos theta. So now we are going to apply the product rule to solve this part. How can we do that? So we have theta which multiply cos theta. So remember the product rule of derivation. So if we have a function f that multiply a function g. So what is the derivative of f times g? So we have f, so derive f and then multiply by g, then plus f multiplied by the derivative of g. So what is f and g in my case? So we have f which is theta and the g which is cos theta. So if I apply this rule, so 2 is a constant, it can just goes outside the bracket. So we need to derive f is theta. If I derive theta, I get 1, and then multiply by cos theta plus, and then I need to repeat theta, and then here I'm gonna derive cos theta. So if I derive cos theta, I got negative sine theta, and then I have to multiply it by 2 theta cos theta. So this is the same as 2 cos theta minus 2 theta sine theta, everything multiplied by 2 theta cos theta. So this is dy over d theta. So now we need to find d theta over dx. So to find d theta over dx, we need to use the inverse of dx over d theta. So in other words, we need to derive the second function x with respect to theta, as we did in the previous slide, in the previous question. So I can derive it, or I can do that on the revision part. So same thing here, I'm gonna say this is equal to, so I'm gonna have the derivative of the exponent, which is with respect to theta, and then multiply by e. So we have e to the power of the same exponent. So if we derive this with respect to theta, we still apply again the product rule. So we have the function f and the function sine theta. So that's gonna give us, so we have 2 that's gonna goes outside. So if first derive theta, we get 1 multiplied by the second function, which is sine theta, and then plus theta multiplied by the derivative of the second function, which is the derivation of sine theta, which gives cos theta, and then multiply by 2 theta sine theta. So that gives 2 sine theta plus theta cos e to the power of 2 theta sine theta. So now, so far I have the derivative of, okay, this is actually the derivative of x. So that is the derivative of x with respect to theta. So now I have to determine the derivative of theta with respect to x. So that is just the inverse. So we have 2 sine theta plus theta cos theta e to the power of that. So let me repeat that. So we have d theta over dx, which is equal to 1 over 2 sine theta plus theta cos theta e to the power of 2 theta sine theta. So finally we need to find the first derivative. In other words, we have to multiply the derivative of y with respect to theta and the derivative of theta with respect to x. So what I have here, I need to multiply it by that one. So I'm gonna do it on the new slide. What I can do is I'll just create a space for that. So I have the first derivative, so which is dy over d theta. So the result is this one. So I have this so I'll multiply it by the second derivative, which is d theta over dx. So we have 1 over 2 sine theta plus theta cos theta multiplied by e to the power of sine 2 theta and sine theta. So I cannot cancel these two brackets because here we have sine inside, but here I have cos. So I'm gonna keep it as they are, but I can simplify these two. But as you can see, 2 is the common denominators. Alright, let me just create a slide for that quickly. So this is actually the result of dy over dx. So you only need to consider this part. So these two can cancel out with these two. So in other words, I can write my expression as so we have cos theta minus theta sine theta, and then I have e to the power of 2 theta cos theta, then divided by the bottom so we have sine theta plus cos theta multiplied by e to the power of theta sine theta. So I cannot simplify these two expressions, so e to the power of 2 theta cos theta and e to the power of 2 theta sine theta, because the exponents are not the same because of the presence of cos on the first one and sine on the second one. So, but I can apply the exponent law for this, because I know that a to the power of n divided by b to the power of n gives, we have a to the power of n divided by a to the power of p. So same base, different exponent. So we have to repeat the base and then we minus the exponent. So we're gonna repeat the bracket as they are. So the whole thing multiply e, and what gonna be the exponent? The exponent will just be the difference between the two exponents. So we have 2 theta cos theta minus 2 theta sine theta. So that's it. So next time, so now you can also try to do the second derivative of the function y with respect to x. So I just got my first derivative, so you're gonna try to do the second derivative as well. So I'm gonna also leave some questions that we are going to try. So I'm gonna find the question from the textbook. So these are basically the end chapter questions.